So today's talk is the best of the best practices for security at scale. And we've aimed this at, it's a 200-level talk, so it's intended for people that are familiar with the cloud and/or familiar with security. And we've aimed it really at three different types of people, either cloud engineers or architects who want to understand some of the developed best practices for how to build secure workloads in the cloud, for security professionals who are looking for security controls that have proven to be the most effective over time in the cloud, and also for managers and execs who are looking for a bit of oversight over projects that their own teams are building for them in the cloud or maybe in a relationship with a service provider. So the agenda today, we're going to use a common architectural example through the things that we look at. We're going to look at a bit of a negative use case to start with, a bit of a bad day in the cloud, and then turn that around and follow the same exact example through these fundamental best practices and show somebody has a good day in the cloud. We'll transition to a little bit of our newly developed strategies around the how, which I'll get into, and then look at a few examples of tools in this space. So I want to start off with the sources of our best practices. Where do we get these best practices from, and what can you get direct access so that you can get this information as well? And for us, it starts off in a number of places. One of those is our cloud adoption framework. This is a document and a strategy sponsored by our professional services team, which is a distillation of the practical experience that they've had working with thousands of customers across the globe over the last 10 years. This really defines how specifically customers should be migrating to the cloud. One of those principles is security, quite obviously. And inside of security are these 5 different areas that we'll use as a structure going through the rest of the talk today. The next level down is our best practices white paper. So this is more specific than the cloud adoption framework. This is 44 specific examples of best practices across these 4 different areas. And this is the exact order I'm going to take them in: identity and access management, logging and monitoring, infrastructure security, and then data protection. I'll show 3 best practices from each of those, so we'll go through 12 of these today. And then the most detailed source for best practices that is available today in the, out in the community is from the Center for Internet Security, who's a source of a number of different best practices across a number of different technology areas over the last 10 years, everything from Android, OS X to Windows, et cetera. We've worked with them over the last year or two to develop 2 specific AWS best practice guidelines, which they call benchmarks. The first, which is reasonably well known, is the Foundations benchmark, which gives about 50 best practices. And the second one, which is not as widely publicized, so if you're familiar with the CIS but you haven't seen the second one, it's called the Web 3-Tiered Architecture Benchmark. And I really encourage you to take a look. It's another almost 100 very specific best practices for how to implement secure workloads inside of AWS. So for every single one of those 150 best practices, the CIS goes into specific detail on what the best practice is, a little bit of a recommendation around and background around why they've suggested it, and then very specific technology detail on how to check to see if this best practice has been implemented through either the graphical console or directly through the command line interface, and then how to actually fix or configure this. And it's an audit guide, but you can turn it on its head. So use these fix recommendations as actually your implementation scheme for implementing these 150 best controls, and then use the check to make sure that that's been done properly. So there's a huge amount of information contained in both of these CIS benchmarks. OK, so today we're going to look at a story that involves 2 different characters. First, we've got Andy. Andy's taken his time and done a good job in learning best practices around security in the AWS cloud. And there's somebody else named Bill. And unfortunately, Bill has not taken the time to educate himself around these best practices. So Bill has a bit of a bad day. Bill is running this very simplified architecture in AWS. He's got sort of a 2-tiered web architecture there with just an arbitrary sort of web front end and some sort of data back end. And both of those are talking to S3, our object store, to fetch some objects. So imagine maybe an image on a website for the web server and just sort of an arbitrary data backup there. But unfortunately for Bill, there's a bad person on the internet. So what this bad person does is he accesses a vulnerability in the web server that Bill chose to install in this EC2 environment. He then is able to get direct access to this internal data service. He goes ahead and changes, he deletes some of the files that are inside of this web site bucket, which might cause the website not to function quite as well. And then the worst thing he does is actually goes and he changes the permissions on this S3 data backup bucket. And he does that because then he downloads the entire contents of this data backup over the public internet. So it's not good. So Bill's doing a lot of things wrong here, right? He's got no application-specific protection between the public internet and his web application. He's only using one AWS account throughout the entire environment. He's not using any internal segmentation between his different tiers or stages of workload. He's given out way too many permissions across this whole entire environment. He's not encrypting any of the data that he's put in the cloud. And finally, he's got no logging, monitoring, or alerting configured anywhere. This is what not to do. So now let's take this exact example and wind it back and look at Andy, who has taken the time to learn best practices, and see what he does exactly. OK, I'm going to take these best practices in the order that we recommend them. So the reason I'm starting with identity and access management is important because that's the most fundamental security control that we have in the cloud. That's the way that you'll start your journey inside of the cloud. You'll configure your self-account, and you're always going to use those account permissions as your primary security function. Whenever I talk about these best practices, I'll always go through the title. I'll just do a couple quick graphics and a summary that I won't just read you. And across the bottom is just 3 checks. Does this exist in our best practices white paper? Hint, it always does. And then on those 2 CIS, the foundation and the web 3-tiered benchmarks, how many times does this best practice appear to give you a little sort of gauge of importance? This first best practice is very clear. An AWS account is the most fundamental security boundary that you can have inside of the cloud because by default, absolutely nothing is shared between accounts. And if you want to share anything between them, you have to make explicit actions. So customers choose to use AWS accounts to segment for many different reasons, maybe different types of data sensitivity, public versus private data. Maybe different application stages like development versus testing versus production, maybe different business units or billers inside of a large organization. And in reality, customers use a combination of these things, maybe a development environment for one business unit using a separate AWS account from a production environment for a different business unit. Limited roles are probably one of the fundamental things that Bill got wrong. Remember that attacker was able to, he got way too many permissions inside of that S3 layer and was able to delete objects and or change different bucket permissions. There's no reason that that web application server should have had the rights to actually modify a bucket permission and or delete a file. All that web application should have been able to do is simply read that file to display it to users on a web page. So using our roles construct and defining very specific permissions on these roles is one of the most fundamental security controls that we have. In addition to this, what we don't want to have are static access keys generated by individual user accounts laying around inside of the environment. What we want to do is use these roles to create temporary security credentials that are only giving very specific time-bound access to these environments, that as soon as that is no longer needed, it goes away. And the best way to do this, to make sure that there are no static user accounts anywhere inside of the environment, is actually to federate. We do this talk sometimes with Atlassian, and they talk about having over 1,000 internal staff needing access to over 100 different AWS accounts. Well, 100 times 1,000 is a lot of static users to have to manage, and especially do identity lifecycle provisioning around provision, password change, deletion, et cetera. Federation allows you to use your existing on-premise store of directory or of identity and federate that into the side of the AWS environment to take advantage of the pre-built rule definitions that you've already created on premises, and especially to take advantage of a centralized place of password store so you don't have to redo all that work in the cloud. So let's take a look at Andy's architecture now. It's the same very simplified web 2-tier architecture with the EC2 layer communicating with the S3 layer. And let's start to build in some of these best practices we talked about. So right away, he sets it up at least across 2 different AWS accounts. So you see there's absolutely nothing inherited between the web server instance and, for example, that S3 data bucket. He brings in specific roles rather than user accounts and uses temporary security credentials. And he chooses to integrate it with through federation. He could do this on-premise. In this case, he happens to choose to use AWS Directory Service. So the second of our best practices are logging and monitoring. The first best practice here is another really fundamental one, and it's very simply to turn logging on for every single service that you're consuming and every account that you're using in every region around the world. And we've made 2 big improvements over the last year that really helps us. First of all, by default now, when you're enabling CloudTrail, which is our primary logging mechanism, it's enabled across all regions by default. And just a couple of weeks ago, we actually changed this. So now we automatically enable, when you create an account, all CloudTrail to be enabled across all of the regions and all the services you're consuming. And we keep that CloudTrail on and running for a 7-day continuous window. So that means that we've enabled logging, the very basic logging by default across all the services you want to use. And this is a big security improvement. Imagine that Bill, when he had his bad day, he probably didn't even know it was happening until a customer called up and said, hey, your website's not working anymore. And then Bill had no ability to go back to his logs and see how long this activity has been going on or where it happened. So turning on this logging here is fundamental. Also, would have been nice if Bill got some sort of an alert when something wasn't working right. And there's a number of features and services we have on top of the platform which do enable automatic monitoring and alerting on top of our logging systems. The two examples that we use here are CloudWatch Alarms and AWS Config. And very simply put, these are just looking at sources of information like logs or state of an object and giving you the ability to either create a threshold or define any other function that, if exceeded, will cause some sort of a trigger like an alarm. For example, maybe you want root logins to your AWS account that's not using a multi-factor token to always be equal to 0. So if that ever happens and it's equal to true, then raise an alarm that can send to a pager, an email, a Slack channel, et cetera. This integration of automated monitoring and alerting is really powerful. And then our last best practice around logging and monitoring is to use that same concept previously around creating separate AWS accounts and extending that to create a specific security account that's separate from the other production accounts inside of your environment, and use that for a few different things. For example, integration and import of all the logs in those other environments. So if a bad thing happens in any of those environments, you still have an authoritative copy of all the logs that were generated. You can use this as a central point of federation, and you can also use this as a point to store sensitive or information you don't want to change. For example, the gold disks or sort of root AMI or AMI's Amazon machine images that you want to use inside of EC2. So Andy does all of these things. And actually with logging and monitoring, it's really straightforward. We've got centralized platforms, including CloudShell, CloudWatch, and Config. And all he has to do to enable these features is really just turn it on. Our third category of best practices is a more traditional one called infrastructure security, where we're really porting a lot of the security good practices that you used to be doing on premises and showing you the right way to be doing these inside of the cloud. Our first best practice here is called create threat prevention layers using a combination of AWS Edge services. So threat prevention layers is a concept that's been around inside of AWS for a while. It was originally created inside of the EC2 environment, inside of our VPCs or private virtual clouds or networks, in order to create centralized networks where you might be doing extra security filtering or control. For example, proxy layers, next generation firewalling, IDS, IPS, et cetera. What we're doing here is extending that concept to take it out of the internal virtual networks and put it out to the edge of our content delivery network, which we call our CloudFront network. And right away, this allows applications that sit behind it to take advantage of a lot of things. It's behind a CDN, so it's very resilient. It's behind our DDoS mitigation service, AWS Shield, that was talked about in this room earlier today, and also allows you to take advantage of our web application firewall, or AWS WAF. When Andy chooses to do this, he gets all those strong controls now much closer to the attacker than it would be if he put those controls inside of his environment. The next best practice here is to segment, but not to segment at the account level, but to create segmentation inside of those accounts, inside of the virtual private networking environments or virtual private cloud environments, using a combination of VPCs and security groups. Security groups, very straightforward. It's just our firewalling construct. So you're able to define layer 3 and layer 4 networking rules, like, for example, maybe only allowing database ports to be going inside of the VPC where the database instance was sitting, or maybe only allowing the web server to be answering back on the same port that the client connected through to start with. These are basic network security best practices, and you implement them inside of AWS using VPCs and security groups. You can see here, too, 30 times it shows up in the Web3 tier and 5 times in the foundation. 35 out of those 150 specific recommendations in the CIS are based around this, so it's a very popular and fundamental concept. And our last infrastructure security best practice, and the one that matches that logo, is to use to always remember that scanning for vulnerabilities inside of the EC2 environments and the operating systems that you choose to use is your responsibility when following our shared responsibility model. So please make sure that you're continuing to look for vulnerabilities and respond to vulnerabilities inside of those environments. And we provide tools to allow you to do this. For example, Amazon Inspector is our proactive, integrated with a platform vulnerability scanning service that allows you to get, as any other vulnerability scanner, lists of services or servers or processes that are known to be vulnerable so that you can take action to patch those. This is one of the fundamental things that Bill did wrong, because you remember the first foothold that the attacker was able to get inside of his environment was through the vulnerability in that web application server that he installed. So if he had used Amazon Inspector, he would have been notified that before the attacker took advantage of it. So Andy does all of these things. The first thing he does is he brings up Amazon CloudFront, the CDN, to get content distribution and some scalability. He brings on the AWS Shield DDoS mitigation service and the AWS Web Application Firewall as well. And you can see these protections are outside of his private networking environment, so they're closer to the attacker, which is definitely best practice. He creates segmentation inside of this environment using a combination of security groups and virtual private clouds. And finally, he's using Amazon Inspector to be doing vulnerability scanning. I'll have a combined graph of this in a second. Okay, our last category of best practices that I'm going to go through before I transition is data protection. Data protection really means encryption. And I'm really happy to say that our global chief information security officer is very, very clear. He's happiest when customers choose to encrypt data that they're storing inside of AWS. It's good for you, it's good for us, and it's good for the industry as a whole. And our first best practice deals with this exactly, to be using encryption and REST across a number of various services that we allow it, that we enable it rather, so that you can be taking advantage of this very strong control. Bill didn't do this, right? So when that bad guy was able to access that internal data backup because of the permissions issue on S3, he was able to download clear text file and take advantage of that straight away. If that had been encrypted using a server-side encryption method with a key that he controlled, even if those permissions were done incorrectly, that attacker would have downloaded data that was absolutely meaningless to him. Our number of different services are pre-integrated with our encryption service. The primary one's called Amazon KMS, or Key Management System. And this is a great way to take advantage of what we call undifferentiated heavy lifting and allow us to do some of the hard work for you. So what KMS does is allow you to continue to make decisions around which key you want to use. Do you want to import your own or trust us to create one on your behalf? Who should be using that key to get access to which data and how? And allow us to do all the heavy lifting around making sure that that encryption service is always available, making sure that that key is always available and it's ready to use if you want it. Because remember, when you're choosing to use encryption, the biggest availability risk against your data is you losing that key or that service becoming unoperational. So let us provide those services to you and allow you to just focus on making decisions around who should use that key and when. And our last best practice related to encryption is around data in transit rather than data at rest. We've seen a big change in the industry in this over the last 3 or 4 years now. Imagine how ubiquitous that little lock is on your browser and banking, et cetera, websites that you visit. Encryption, and we have a number of services where you can enable encryption in transit. The example I'll show in a second is between our CloudFront network, our CDN, and the Origin web server running inside of EC2. And this means, especially when that data is traveling across public networks, private networks, virtual networks, et cetera, that anybody without that key cannot get access to the contents of the data. Okay, so let's pull these in as well. Andy is choosing to use our KMS service, where he's choosing a key that we've created on his behalf to encrypt everything that's inside of his S3 buckets. He's maybe choosing not to encrypt some of the images in his public website, since that's public information anyway, but he's choosing to encrypt especially the things in that private data backup. He's using a data encryption key that we're managing on his behalf. And in this case, there's a number of places he could do it, but he's enabling SSL or TLS encryption between a CloudFront CDN and his Origin web server. So if you look at Andy's architecture here, it's fundamentally the same as Bill, but we've brought in a number of AWS-supplied security services that we've already pre-integrated across the platform, and that allows Andy to take advantage of a number of these best practices straight away. Okay, now let's transition a little bit, and that was the what. What do you need to do to be secure in the cloud? And what you need to do to be secure in the cloud is follow our best practices. But now we want to look at the how. What is our strategy for how you actually going across to implement this? And you can't just get straight to perfection in the cloud. We're all, as an industry, going through a learning process with this now and evolving and maturing together. You don't just go from crawl to run. Anybody, what's the step you have to pass through in the middle? Walk. Good. Mario didn't just go from 8-bit to 64-bit. He passed through some phase in the middle. 14-bit, no. 16-bit, yes. Some people say 32. I haven't found a 32-bit Mario yet. If you find one, let me know. And what we say, you don't just go from a 0, sort of struggling your way through cloud security inside of AWS to this AWS cloud hero. You've got to pass through some level in between, which we call pro, because it kind of rhymes. But I think better is to think of these 3 phases as click, script, and commit. So click is the manual application of these security controls, these security best practices that we talked about. Click is interacting with a console like we all do when we're starting off on our journey. And click is remembering to implement, let's say, these 150 things from the CIS throughout the environment. If you do it right, it works great. But it's fundamentally not very scalable. It's error-prone, et cetera. Script is getting the same outcome, which is application of the security controls, but in doing it with an inherently scalable and repeatable method. We've got a lot of different platforms. I'll show you a few, a lot of different services. I'll show you a few in a moment, where you can basically automatically take action to implement and check all these different security controls. But that's not the ultimate goal. The ultimate goal is actually commit. And what commit means is shifting the application of these security controls, what we call all the way left, inside of the automated build processes that are creating these dynamic virtual environments to start with. And the goal for commit is very straightforward. We never actually allow any object to be created inside of the AWS cloud unless it's known to meet our security policy. And that's a really powerful thing. And that's the ultimate goal for how and where you should be applying these. And no organization starts off in the cloud and goes straight to commit. Yeah, you have to go through this crawl, walk, run. You'll start to interact with the console and manually apply these best practices, which is click. You'll move to using some sort of automation and making sure that you're applying these consistently, but after they've already been created. And you'll slowly evolve into using commit to actually push these security controls down into the security as infrastructure as code definitions that are the basis for all of these objects to start with. It's a really powerful concept. We'll actually be talking about this more next week in other public conferences that we have here in Australia. They're called Dev Days. There's one in Brisbane on Tuesday. There's a second in Melbourne on Thursday. And I'll be going into more specific detail on our strategies, technologies, and tooling around commit. There's a lot of tools that you can take advantage of now. I talked about Amazon Inspector already. That's our proactive vulnerability scanning tool. Works across Windows, Linux, and other operating systems that you have as a choice to use inside of EC2. And it's a really important step. I can't tell you how many customers will come to me and say, well, I'm using the cloud, so you take care of the vulnerabilities for me, right? And in some cases, that's true. But if it's an operating system that you've chosen to install, please remember that you continue to be responsible for patching and maintaining that operating system moving forward. CloudWatch Events is another powerful tool for automation. So CloudWatch is essentially one of our operational monitoring platforms. It's looking at log sources and activities across a number of different areas. And it's creating, let's say, that kind of traditional SOC or NOC view of the changes in status over time. CloudWatch Events is a triggering system built inside of that that allows when one of those bar graphs is raising over a certain threshold to take another action. Right? And this action could be a lot of things, either a remediative action automatically on the platform or a notification action through a page, et cetera. And the most powerful tool that we have for automation is based on Config. Config is our service that monitors state and records when it sees any state change inside of the environment. For example, maybe a security group, that firewalling construct, changed and is now allowing a new port inside of the environment. Well, it would record what it looked like before, what it looked like after, who took that action and when. And this state change, when integrated with config rules, allows you to be doing any arbitrary action that you can define as code in response to that state change. For example, using Lambda, which is our serverless execution platform, where you can implement any code of your choosing written in a number of different common languages. You can start to define any really action inside of this environment. So for example, if I see that state change and that security group or that firewall change, well, maybe I want to, A, identify the user account that caused this change, B, temporarily disable this user account, C, identify what the previous configuration of that security group was, and C, return it to that state. And this is where we start to get automated incident response in the cloud, which is another powerful advantage. These are big talks in and of themselves. We did a really good deep dive into this, including code examples and tooling at our last reInvent conference. That's a link to that talk if you want to go into more details with any of this. OK, so I just want to recognize that we're in a stage in the industry now where our most common question from customers related to security is no longer, is the cloud secure? Yeah, we've moved into a phase now where customers are asking us the much more practical, how do I be secure in the cloud? And these best practices are how to be secure inside of the AWS cloud. We've defined these best practices, we've published them, we've created architectural guides and white papers, and we've given you all of the information that you need. All you need to do is just turn it on. It's easy to prepare yourself before the storm. Just remember to take your umbrella before it rains. It's easy to stay secure inside of AWS Cloud. We've done all of the hard work for you. Just remember to turn these features on. Our call to action is very, very clear. I want everybody here to get their phones out, hold them up to the screen, take a picture of these links, go out there and download our security best practices white paper, download both of these CIS benchmarks, the Foundations benchmark and the Web 3-tiered benchmark. Start to learn these techniques, practice with them inside of a closed environment, and migrate these security controls out into your production environments of AWS as soon as you can. Thanks very much for taking the time to come today. I really appreciate it. That link on the bottom is to a number of other talks that we've done in Australia, specifically around security. And thank you for doing the best to follow these best practices and keeping us all safe in the cloud. Thanks.